All right, we're going to go ahead and get started. I'd like to introduce our keynote speaker. For those of you in the Charlotte, Mecklenburg County region, I'm sure you've seen him. Brad Panovich is the chief meteorologist at WCNC-TV in Charlotte. He is also an adjunct professor at the university in the meteorology department at the University of North Carolina, Charlotte. And he serves as an incident meteorologist for the Charlotte-Mecklenburg Emergency Management. He earned his degree in atmospheric science from the Ohio State University. His career spans from Dayton, Ohio, Traverse City, Michigan, and New Orleans, Louisiana. But he spent the past 20 years here in the Carolinas at WCNC-Charlotte. So I'm going to pass this on to you, and I'm looking forward to learning more stuff.
All right, thank you. It's quite the introduction. Thanks for having me. A lot of folks are probably wondering why we have a meteorologist speaking to you today. I wanted to talk about a subject that's kind of near and dear to my heart. One of the things about me, for those who don't know, I never wanted to be a broadcast meteorologist. I never wanted to be on TV. I just wanted to be a meteorologist. When I grew up, most of the meteorologists I saw on TV, they weren't meteorologists. They were TV personalities, and I wanted to be a scientist. So I never in a million years thought I'd be doing this in front of a camera. So I approached my degree in atmospheric science with no communication background, no journalism. It was strictly science. And then I stumbled into TV by accident. As some often do, I graduate from school. There's a hiring freeze in the government, so I couldn't go work for a National Weather Service because there wasn't any openings. My buddy said, do an internship at a TV station. And I did an internship at this TV station in Columbus, kind of going in thinking, that's not what I want to do. I go in there, they have their own C-band Doppler radar. They've got all these silicon graphics machines. I'm a pretty big tech geek as well as a weather geek. And I was like, wow, this is pretty cool. So I started diving headfirst, building graphics, doing all these things for the station. And the news director comes in and asks, who's doing all these graphics? And the chief meteorologist is like, our intern Brad is. And so next thing I know, I'm getting a job offer to be a weather producer, which I had no idea what that was. Basically, we want you to forecast and build graphics, but not be in front of the camera. I'm like, that's fine. So they pay me to do that for a while. I have my resume online and I get a job offer to be in front of the camera. And it was in Dayton, Ohio. They call me and say, hey, would you be interested in doing the morning weather at this NBC station? I'm like, sure. So in my business, you have to have a degree in science, but you also have to do a resume reel. It's basically like a demo tape that you send off. And I had one suit at the time that fit horribly bad, put it on, did my demo, and I learned about the TV business literally by being on TV. So just so you know, most people on TV, that's the easiest part of the job. The science part is the hard part. And that's what I thought all through my schooling and early in my career, that the hardest part about my job was going to be forecasting the weather. Well, little did I know that that was going to be the easiest part of my job. What has really become part of the lexicon in at least broadcasting and the weather enterprise is social science. How do we use social science to get people to understand the forecast? So go ahead and hit the next graphic here. So as I mentioned, I thought the hardest part would be the forecast. People often, will say, I'll show you some jokes here in a minute, that, we get it wrong all the time, right? Well, we really don't. That's the funny thing. But why is this perception that we always get it wrong? The biggest problem now is actually communicating the forecast. It really is the hardest part of my job, even though I do it for a living. And even in this day and age where everybody's got a cell phone with bevy of information, it's actually getting more difficult because the information is drowning people. They all think the information is the same. Go ahead and advance. So I want to talk a little about why we're getting so good at forecasting the weather. This might come as a shock to you, but we are getting really good. We have great modeling. We have incredible data collection. We have great visualizations, which a lot of you help us with tremendously. And then it has really all led to increased accuracy. The data collection is pretty stunning. One of the things during COVID that really affected us in the weather enterprise was the lack of aircraft data. People don't realize every commercial aircraft that takes off and land collects weather data from the ground up until its flight, cruising altitude and lands. Well, when nobody's flying between Europe and the US or Asia and the US, guess what happens to data over the ocean? It goes away. We had a 20% drop in weather data collection in the upper levels of the atmosphere because of COVID. That affects you as a meteorologist because your data goes down. I talked about cell phones. As much as I hate weather apps, these phones are collecting data for us. There's a barometer in here, right? Everyone's got a barometer in their phone. It's collecting data. That's going into the modeling. A lot of Android devices have a temperature sensor for battery temperature. You can run a quick little algorithm and figure out what the environmental temperature is. And then you probably some app that you accepted to allow that data to go off to a third party who's packaging it and reselling it to IBM or AccuWeather, and they're selling that data to modelers to help forecast the weather. Even some Amazon and FedEx trucks and UPS trucks are collecting weather data as they're driving around delivering. So this data collection is a huge part of this, and we're collecting more data all the time. Go ahead and advance. Feels weird not having a clicker. I'm on TV. I'm like, I have no control over these graphics. So modeling, we're not talking about the ones that run on runways here. We're talking about numerical guidance, numerical modeling. The public's become very aware of modeling, which is great. The problem is the public thinks modeling is a forecast. It is in a sense, it's a computer forecast, but as meteorologists, we refer to it as numerical guidance. Okay, go ahead and advance. The guidance is a tool to help forecast, but you can get incredible imagery, and I'm hoping this plays. This is actually a pretty cool simulation. I'm hoping it'll play at least part of it. Oh, it actually has music. Amazing. So what you're looking at here is actually a complete model of a supercell thunderstorm using data collected from storm chasers. They're not just collecting awesome video, they are collecting data. They use Doppler on wheels, which are dials, Doppler on the back of trucks, collecting data to do these amazing visualizations of a supercell thunderstorm. So what you're looking at is the updraft rotating conductions of the plants, and that's what a supercell thunderstorm looks like a giant infill cloud. I'm just gonna let this go a little bit because let me see how spectacular it is. Just in the past 5 to 10 years. That's part of this animation. I hope it plays up great. Fluid dynamics of what's going on. And of course, it doesn't go that far. But it shows us the inflow and all the dynamic processes that are going on in these supercells. So the modeling is amazing. We're also collecting a ton of data. Now, a lot of folks think of drones. They think I have 2 drones, the small drones, DJI, that a lot of us use, camera drones. But many folks don't know that the Global Hawk that NASA has, as well as NOAA has a couple of Global Hawks, fly upper air missions continuously around hurricanes now. So we're collecting upper air data using drones that were military drones at one point. NASA, I think, owns 2 of the Global Hawks now. I think NOAA just bought one. We also have sail drones, which are little sailboats that float on the ocean surface and go out in the water and collect salinity and sea surface data into hurricanes. This data has really been a huge asset to us because before, the only way we could collect data over the ocean was the flights, hurricane hunters, or a ship or a buoy. So you need to have more data over the ocean, and the drones are really helping us out. So the data collection has been pretty incredible. Go ahead and advance. There we go. Satellite data, been amazing. I can actually probably should have added GOES 18, which is up there now as well. It's not animating. Oh, bummer. Let's see if it animates here. So GOES 16, 17, and 18 were launched within the last 6 to 7 years. And the amazing thing about this satellite data now is that we're getting 15 to 30 second updates at resolutions that are less than 500 meters. So the data and the resolution is just absolutely amazing. And we're seeing things on satellite that we can't even see on radar. If you live in Charlotte area, we live in a big radar hole for Doppler radar. Well, I can actually see the cumulus clouds developing on the satellite imagery long before the Doppler radar will pick up a drop of rain. We can actually see in the animation sometimes a rotation within the thunderstorms from outer space. We've also got the global lightning sensor on both of these satellites that now detects flashes in the cloud. We can detect lightning over areas where we don't have lightning detection, like open oceans or areas where there's not a lightning detection network. So in this imagery, one of the cool things you see is these overshooting tops. Those overshooting tops over the updrafts are labeled. Those are actually going up into the stratosphere. So you're talking up there around 60, 70, 80, 90,000 feet up. And when you tap into the stratosphere, you're creating a lot of severe weather near the surface. So this data is amazing. How many of you guys ever seen the movie Twister? All right, one of my all-time favorites. Cult classic, right? Do you remember what the GOES satellite they show at the very beginning? What number that one was? That was like GOES 7. So just to show you how long we've come, now we're up to GOES 18. So it's pretty incredible. Go ahead and advance. So we've gotten really good. And I actually have data. I've got receipts, all right, to show you. I'll say Hurricane Center forecast, okay, the track, just since 1970. If you look at the 24-hour, 48-hour, 72, 96, and 120-hour forecast, look at the vast improvement on track forecast over time. It's incredible. If you're wondering why the 120-hour doesn't go back further, prior to about 2002, we didn't have a 120-hour forecast. We only went out 3 days with the cone. Now we go out 5 days. Guess what's coming down the road? 7-day cone, okay? That's how good we're getting. And if you look at some of these, basically right here, the 120, I'm stepping out of the camera, you're probably get mad at me. The 120-hour forecast right here, if you go back, you can draw a line and see it was as accurate as the 96, the 72, and the 48-hour forecast in 1995. So just think about that improvement. Now, 5 days in the future is as accurate as a 2-day forecast was in 1995. It's not that long ago. And the 7 and 10-day forecast you see on your nightly news, you know, used to do a 5-day forecast. It was a 3-day forecast way back when, if you're old enough to remember that. So the fact that we do a 10-day forecast, it's getting better. So what's going on? Let me go ahead and advance the next graphic here. But we still deal with this. All right, I hear this joke on average, maybe 15 times a week, okay? I left the percentage blank because depending on who's telling the joke, that number varies. Sometimes it's 80%, sometimes it's 70%, sometimes it's 100%. But we hear this all the time. And I often ask myself, why? I hear this more now than ever. I don't know if it's social media, but I hear it more than ever, even though the data tells me the exact opposite is happening. So what is going on? Go ahead and advance. Got some other jokes, right? You guys are probably saying, go ahead and advance. Go ahead and advance. These are just my jokes that some were put out there. Go ahead and advance. I mean, this has kind of become a part of our culture. You know, I don't know how many times I work in the news business that we'll hit a soundbite from somebody and they'll say, the weather's unpredictable. How many times have you heard that? Or it came without warning. That's like the common thing. Like every hurricane, tornado, severe weather, flood, there's always some soundbite. Oh, we just had no warning. The thing is, there was a warning. There always is a warning. The problem is, as I mentioned, the communication of the warning is the problem. If you think about that hurricane forecast, I was just thinking today, you know, is the anniversary of Hugo. And in Charlotte, we got caught really off guard from Hugo, right? Because people thought hurricanes were coastal events. So people in Charlotte, they weren't ready for Hugo because it's not at the coast, right? And what happens? Hugo moves 30 miles per hour, intensifies at landfall, goes up I-77, hits Charlotte as a Category 1 hurricane still. And Charlotte is a beautiful tree canopy. At the time, knocked out more trees and power than had ever happened in the city. It was Duke's #1 power outage storm up until the ice storm in 2002, which people forget that ice storm was pretty bad. But it kind of caught people off guard just because they weren't ready for it. Now, was Hugo a surprise storm? What was for the people in Charlotte, even though it had been out in the ocean for about 15 days. It just goes to show you the communication, the perception of the threat was a big problem. Go ahead and advance. I think there's a couple more in here. So how accurate are we? Well, depending on the methodology you use, most sources for weather, and I say all sources, are about 80 to 90% accurate for the day one forecast. But At my station, I've done something because this is just something I do because it's not just for myself, but it's kind of a way that I kind of keep myself in check. I keep a spreadsheet of my accuracy. And it's not so much to say, Brad, you did a great job, bad job. It's really to kind of recognize a bias. If I start having a cold bias, a warm bias, I start correcting myself. And if you don't keep track of that, how do you know how well you're doing? We're about 94 to 95% accurate. So the good news for me is that we can improve on this, on the averages for some of the other sources. But the thing that people also forget about forecasting the weather, I have to forecast 365 days a year. So even if I'm right 94 or 95% of the time, that still means I'm going to blow it almost 1 month a year. And that's still not acceptable for a lot of people. I always think we're like linemen and officials, right? Nobody notices until we blow it, right? When you're doing your job, it's like, oh, you're supposed to be doing that. But when you mess up, people really notice. So go ahead and advance. So what's going on? I ask this question all the time. Why do people think we're wrong when clearly the data shows we're not? Well, I won't get on my soapbox with apps because I love apps, right? I've got tons of weather apps on my phone, but you know, there's over 10,000 weather apps in the iOS store alone. 10,000. It's one of the most popular categories for apps. We've got all these great apps. You probably heard of them: Dark Sky, AccuWeather, Weather Channel, Radar Scope, Carrot Weather. If you haven't downloaded that, it's hilarious. And a lot of these apps, I read a lot of tech blogs too, and I'll see reviews of weather apps, right? The weather app reviews are always great UI, great visuals, fun to use. I never see anything about accuracy. Like, how many of you use Apple Maps when it first came out? You're all mapping people, right? How was the data in Apple Maps when it first came out? Okay. Would you keep using it even if it was a really cool interface or the mapping looked really awesome? The data's got to be important, right? But for whatever reason, the public doesn't really care when it comes to weather. It's like they just think the data is all the same. And so they don't distinguish accuracy from app to app. So go ahead and advance. Luckily, there are websites that keep track of it for you. So for Charlotte, I actually went back and looked at August. And these are a series of apps that track. Forecastadvisor.com actually tracks these. And that's actually that Valselia app, that Forenza, is pretty good. The Weather Channel, Weather Underground, they were all in that about 80% range. Okay, go ahead and hit the space bar. Our station was 95.8% accurate. So I often ask myself, okay, how much work am I doing to make me 15% more accurate than an app? Well, it's actually pretty important, especially on high impact days. 15% difference, especially over a year, can be a pretty big difference. So this tells me humans still have a play in this, all right? We can improve on the forecast from just strictly, and by the way, most apps, it's just a computer automated forecast. That's all it is, from one model. Sometimes the app doesn't even tell you what model it is, which to me is frustrating. It would be great if they would tell you where the source of the data was, but they don't. Oftentimes it's just, here's an app. Like when Google pulls up the weather, a lot of people search Google, they use Siri or Alexa. Nobody really knows where that data comes from unless you dig into the data a little bit more. And that's where most people get their forecast from. And guess what happens when that forecast is wrong? You know who gets blamed? Not Siri or Google or Alexa. I get blamed. Okay. And I've seen this oftentimes. People are like, oh, you guys blew the forecast all the time. I say, well, that's not what I said. Like, oh, I don't watch you. Well, I can't be blamed for a forecast I didn't make, but I get blamed all the time. Go ahead. We'll show you the yearly accuracy. So if you live in Charlotte, last year, the Weather Channel did pretty good for you, which, by the way, the Weather Channel app, and this is a little behind the scenes, it's not even owned by the Weather Channel. It's actually owned by IBM. It's a completely separate company than the Weather Channel. The weather.com and the Weather Channel is owned by IBM Weather, and WSI, which is actually the graphic system we use at the station, is a completely separate company from the Weather Channel TV channel. And they actually have a contract to use the data online between the two sources, but they're not actually the same company. So when people, my good friend Jim Cantori, people complain to him about the Weather Channel app, he can say it's not even the same company. So, and people don't know that. Just goes to show you about the number of data sources people use that have no idea where it comes from. Go ahead and hit the space bar. I'll show you how we did last year. about 96.1. Not bad. And again, this is only the 24-hour forecast, okay? We can show you long range forecast, which I do have on the next slide. Hit the space bar. I think it's on the next one. So obviously, as you go further into the future, the bottom axis is days into the future. Some of the apps don't go out very far. But just so you know, when people are getting married and they email me or Facebook message me what the forecast is for October 2024, because they're getting married, I have to tell them, I don't know. Here's climatology. And the fact when you see a long range forecast for like a Cat 5 hurricane in the Gulf of Mexico in 10 days, someone's telling you something. Okay. The accuracy goes down with time. And that makes sense because if you think about small changes in the forecast multiplied by long time spans, the difference is big. I always use the example of if there's a cold front coming tomorrow and I think it's going to arrive at 1, but then the speed slows down 5 miles per hour. That's not going to change the time by a whole lot. It'll be a little bit later in the day, but it'll still be tomorrow. Now, if that 5 miles per hour is for a front I'm forecasting next week at this time, now you're talking like day and a half difference. So small changes multiplied by big time frames can make big differences in the forecast. So if you think about subtle differences in the forecast, and you're looking long range, that could have huge implications. So one of the things, I'll give you a piece of advice. Don't ever look for rain forecasts more than like 5 or 6 days in the future. You don't change your plans to go to the beach because you see a chance of rain next week at the beach. I got news for it. It rains every day at the beach pretty much, except for this week. We have some nice high pressure in control, but I get that all the time. People pull up their app and they're like, oh my gosh, it's going to be a rain out at the beach. Should I cancel my plan? I'm like, 80% chance of rain for 15 minutes, 5 minutes, or all day. The app never really tells you that, right? And I could have done this whole presentation on chance of rain, which is really confusing to the public, because it is really confusing. The way we interpret it and know it and the way the public uses it completely different. But that gets to the point of my presentation today. Communication of the forecast is the hardest part of the job. So go ahead and advance. Okay, so as meteorologists, we have to do something really careful. We cannot be modelologists. There's a lot of these people online. Hey, I'm a weather social media guy. I'm just gonna post weather models nonstop. And I'll put a disclaimer on there, not a forecast. You see a lot of this. Over-reliance on model data instead of sound forecasting has really caused a lot of us not get very good accurate forecasts. And the reason is numerical weather guidance is called guidance for a reason. These are tools. Tools help you build a forecast. They don't make the forecast for you. And just because the public has access to tools doesn't mean they know how to use them either. I can go to Home Depot and buy every tool my contractor can. I have no idea how to build a house, okay? Just because I have access to the tools doesn't mean I know how to use them. And everybody has access to the tools now because of this. And they think they can make a forecast and they end up not doing very good at it. Go ahead and hit the button. And this will really hit home for a lot of you guys. So people who over-rely on technology end up doing silly things. So GPS, man, people do not know how to get around without GPS anymore. I mean, so this is not a sexist thing either. This was just happened to be a woman. It was not, could have been anybody because a lot of men have done the same thing, especially out west, driving down fire roads because Google Maps told them to. She turned left because the GPS told her to turn left. There's a lake there. She just kept turning left because the GPS told them to. We do this a lot in weather. The model says it's going to do this. Well, it's sunny outside. It's not raining. Should we keep forecasting rain? But we end up over-relying on the data. So I'll give you a good example that you guys can relate to. One of my favorite GPS apps on my phone, and yes, I use them, is Waze, right? How many guys love Waze, right? I heard somebody talk about Waze earlier. Who in here could tell me why Waze is such a great app? Told you where the police are. Who else said something? Yes. All three of you mentioned something. What you said? Police, crowdsource, and what'd you say? Two-way communication. All right. So obviously Waze is owned by Alphabet, which is Google, right? Okay. they're the backbone, they're the AI, but there's something in the AI that makes this app great. And you all three mentioned it. People, crowdsourcing. What an amazing concept. Let's take the best of AI and have people augment the AI to make it this amazing app, right? Why the heck isn't anyone doing this with weather? I really don't understand why not. Like, why aren't we taking this great model data, using a model blender and having a meteorologist quality control the data and have local meteorologists in different parts of the country, which know 20 years experience here, 20 years experience here, tell you the forecast. All right. So don't steal my idea if you're going to go do that, because it will be awesome. It'll be like the Waze of weather. But what happens right now is what people are getting on their stock weather app is just the AI. There's no human. Now that's just from the accuracy standpoint. I haven't got into the communication part because that's where I come in. The communication part is a big part of this as well. Go ahead and advance. So how do we fix this? Well, one of the things that we have been doing in the weather enterprise is we've been studying social science, like how people use our data and how they interpret. It really started with the Super Tuesday outbreak, tornado outbreak back in the 2000s. They went out, it was February, so it was Super Tuesday, primary night. There was a massive tornado outbreak in central Tennessee, and the fatalities were, I think 56 or 60 people died. It was a well-forecasted event, 3-4 days ahead of time, high risk. We know tornadoes are coming, they're coming, everybody here's where they are, pinpoint, and still 56 people die. As a meteorologist, it breaks your heart because you're like, here's what's happening, we know it's happening, and people still die. So they went out and they started doing surveys or basically interviews of the victims. And instead of having meteorologists who are very biased and are going to lead with certain questions, they hired social scientists to go out and conduct these surveys. Like, where did you get the warning? What did you do? How did you do? Most of the people responded, very interestingly, that they knew there was a threat. They didn't think it was going to happen to them. It was February. They were distracted by news of a primary election night, and they couldn't confirm the threat because it was at night. So they didn't seek shelter or do what we wanted. So this really kind of opened the eyes to a lot of the people in the weather enterprise, like, hey, we got to do more than just issue a forecast, because a forecast is accurate for us, but it wasn't accurate for the public. And I had a professor who said this once to me. He says, you know, a tornado warning doesn't verify unless the people that are being warned for act upon it. And he was very right. And so we've kind of taken this to task with us and start putting products out that are more, I wouldn't say easier to understand right off the bat, but kind of talk more about uncertainty. So Ensemble Forecasting is using all the basically all the options that are available in the guidance. Instead of having a deterministic forecast, which is a binary yes, no, we're going to show you the range of possibilities from lowest to highest. And so you probably have seen these with the hurricane force winds or tropical storm force winds, these beautiful plumes, which show, instead of just a line where the hurricane's going, here's where the strongest winds are going to be, and here's the chance of you being impacted by that. These mediograms are great. I love these. We call them Schreff plumes. This is for snowfall, which I should think every snowfall graphic should do this instead of just saying this is how much snow you're going to get. There's the high end, the low end, and the mean. So you got a range of possibilities, which to the public shows you uncertainty, but also sets expectations. Like, we could get 7 inches, we could get 0, but the mean is probably going to be somewhere in between. And so it gives you a better way to communicate. So then when the forecast is 1 or 2 inches, people don't go, oh, you blew it. Said, no, that was within our range. Go ahead and hit the space bar. So we started doing things like talking about forecast confidence. It's amazing when you talk in human terms with people about confidence. Like, there's a person that actually has, I would say, I don't like using the term gut feeling, but a lot of humans interact better when you say, what do you think? What do you feel? How certain are you? This actually helps people take threats more seriously. Go ahead and hit the space bar. So we started using social science more and more to issue forecasts to make the data more usable by the public. One of the things we noticed, people like hearing from people, okay? As much as people love apps, it's different when somebody tells you instead of just reading it off the screen. The technology wasn't very good at conveying threats or uncertainty at all. For instance, the icon on my phone app for a pop-up thunderstorm looks like the same thing for severe thunderstorms, tornadoes, and hurricanes. It doesn't really distinguish what type of thunderstorms those are going to be or what time sometimes the threat is. And threats for sure are really difficult for people to perceive off of an app. People need to confirm threats. This is something that came up in the research again and again and again. When there were tornado warnings, the first thing people do, they don't seek shelter. They look to confirm the threat with other people. So back before social media, the one thing I'll say social media has been great for, people used to call their neighbor or talk to a friend like, hey, did you hear there's a tornado warning? Oh yeah, I heard it. So they would have to confirm it with other people. Well, social media has shortened this time span up because now they can look on their feed and say, oh, yeah, look, I see other people are seeing it as well. So that's just a human nature. People like to confirm the threat. They have optimism bias. It's not going to happen to me, but if they see other people reacting to it, it's like peer pressure. They tend to react as well. The other thing is, as meteorologists, we try to get away from this. We think like meteorologists. We don't think like the public. And that makes it really hard to communicate the forecast sometimes. Those are certain things I take for granted that I understand that most of the public does. And you probably deal with this. I deal with it more than anybody. People have no idea where they are on a map. I mean, every day I'm like, I'll show a map of a snowfall event or a rainfall event. The first question is, how much here? And I'm like, that's on the map. And it's like, I don't know where I am on the map. And you really start to realize a lot of the public has no idea where they are on a map, okay? And some of our best and most effective snowfall graphics, believe it or not, are town and then list of cities or totals, just a simple list, text list, seems to be way more effective than a map of contoured snowfall totals because people don't know. I mean, there's a huge group of people. So you still people that do know where they are on a map. So I end up having to produce like 3 or 4 different graphics to reach about 80-90% of the audience. Some people are visual, some people like text, some people like words. And so you got to really kind of think about that in all aspects. And I think technology can help us here. This is why I'm not anti-technology. I'm actually love technology, but I think the best marriage is technology and people working together. You get really in trouble if you rely on one more than the other. And really, you can be too human and not have enough technology to keep you in check. That's where my spreadsheet for accuracy comes in. It keeps me in check because I can think I'm doing a great job and then look at my spreadsheet and go, oh, I'm not doing so good. Or sometimes I feel like it's cold in here. And then I look at my Nest thermostat and I'm like, no, it's the same temperature it was yesterday. So that happens to me a lot. You just you have some human traits that make you think differently. Go ahead and hit the button. So how do we make, people take weather warnings seriously? Because this is what I think about. Honestly, on any given day, like a day like today, your app's probably going to do a pretty good job. It's sunny. There's not a cloud in the sky out there. The worst thing you got to worry about today is rip currents and the huge swell coming from Fiona out there. Otherwise, the weather today, I could spend all day trying to figure out if it's going to be 89, 90, or 91, but nobody knows the difference between those three. You go outside, unless you have a thermometer, those all feel the same. But I used to early in my career spend a lot of time sweating about, man, is it going to be 91 or 90? Nobody cares. It's the same temperature, right? So I spend more effort and time on high impact severe weather events. And so this is what I lose sleep over. I literally have this dream of people not listening to my warnings. You probably had this dream. I remember forever after I graduated from college, I had this dream that there was an exam for a course that I signed up for that I never went to. And then I had to go take the exam and I'm like freaking out, right? Okay, that dream has transitioned for me to like, I'm at like a state fair and I know there's a tornado coming and I'm running around telling everyone to seek shelter. And they're just like, whatever, I'm eating popcorn and corn dogs and no one will listen to me. I'm just like, and so I have that dream all the time, but sometimes I feel like that on the air. There is a tornado coming or there's a flash flood coming or this, and people are like, oh, I had no idea. And we'll do a soundbite like, we didn't know, we had no warning. Because man, I take for granted, people don't pay attention to the news. They don't really follow what's going on day to day. So we have to look how people can react to these warnings. People will know they're in a risk. It's amazing how many people, if you say, we're under a tornado watch? Yeah, I knew there was tornadoes today. Didn't think it was going to happen to me. Didn't think, it's like every time there's like, some horrible mass murder, you interview the neighbor. Seemed like a normal guy to me. That's like every soundbite, right? For weather, for us, it's like, I didn't know. I think it was going to happen to me. Happens all the time. And this is one of the things, when I worked in New Orleans, this one to me always stuck out with me. Your level of preparedness is only as good as the memory of the last disaster. Okay. Pre-Katrina in New Orleans, you had 2 generations of people who had never experienced a significant hurricane. They had evacuated for 10 hurricanes from high school to college to their adult life. So guess what happened? I'm not leaving for Katrina. I left 10 times and nothing happened. Problem is, it was the 11th time that you had to leave. And so if you talk to, when I lived down there, everybody under the age of 50 were like, no big deal. Anybody who was around for Betsy or Camille, first one's out of town. Now, everybody who went through Katrina, guess what happens when there's a storm in the Gulf? First one's out of town because they remember. It's really hard to convince the public sometimes about the disaster that's coming. I remember we were talking earlier about Florence and Matthew and trying to convey to people like in Lumberton, where the Lumber River reached the record crest. People, 3rd, 4th generation of people, they had never seen water like that. So how do you tell them, hey, you're going to see water this high? Like, I've lived here all my life, never seen it, not leaving. And I remember talking to one family after Matthew, they got flooded. You tell them it's a 1,000-year flood, right? Guess what? 2 years later, another 1,000-year flood. It's just really hard to convey that. Like, your imagination of the disaster is not really in grasp of most people. So as we go forward in the future, it's going to be hard with climate change to tell people about events because their level of preparedness is only good as their memory of the last disaster, but also of what's happened in the past. There are things that are going to happen in the future that has not happened to anybody before. And you can't use the past to judge how you're going to react to future weather. Like in Charlotte, one of the things we deal with is we're a very flash flood prone city. And we're also a very fast developing city. So a lot of impervious surfaces, a lot of flash flooding. In the future, rainfall rates are going to increase. So people that don't have flood insurance don't live in a floodplain and they think, why do I need flood insurance? Well, as my friends at Stormwater Service know, one clogged up storm drain and your house is flooded and your homeowner's insurance doesn't cover it. And the floodplain changes all the time with development. That's the other thing a lot of the public doesn't realize. So these things are going to be happening. Folk science. I know. So you guys are, what do you mean? Folk science or myth? I deal with this a lot. Brad, I live next to the river. The river always stops the storms, or this mountain blocks it, or the nuclear power plant will block the storms or cause the storms. We get a lot of what I call folk science. People have these misconceptions about the mountains stopping certain things or forming certain things. And that actually, those long-standing myths can actually affect people's reaction to severe weather. Go ahead and hit the advance. This is where I need my clicker. Okay. So this is kind of where we are. And this is actually how we now treat weather. We've got integrated social, behavioral, and economic sciences working together. We've got grid-based threat probabilities, observations and guidance. There's me, the forecaster, got my hairline and everything. Threat grid tools, usable output, and then effective response comes before verification, okay? So this is a whole new mindset for meteorologists, but I think it should be a mindset for anybody in the science of in sciences or data, because what we think is verification doesn't matter. Our customer needs to be able to verify it for us, how they react. Like if I'm a salesperson, my verification process is a sale, okay? For me as a meteorologist, my verification forecast isn't getting right on my spreadsheet. It's that everybody sought shelter when there was a tornado warning, or when I said there was going to be rain, they think, and it rained, they all knew it rained. My worst thing for verification is severe weather. I don't want anyone to never not get a warning. And thank goodness for phones. There's one thing that's great about wireless emergency alerts. We can get the warnings to everybody. They don't have to watch me on TV. They don't have to follow me on social media, have our app. Your phone's going to get it. So go ahead and advance. So I started playing around with ways to communicate more effectively. Okay. So one of the most confusing terms in weather that I found in my career has been watch and warning. Even people that work in my newsroom get them confused. Like they'll write a tease to us. And, tornado watches are typically up for several hours, right? That means the ingredients are there for a tornado to form. Well, the toss to me one day was, hey, Brad, we're under a tornado warning for the next 4 hours. I'm like, what? No, we're under a watch. And this was someone that works in the news business. And so just getting a simple chart that I threw together one day on a run, came home, it could not believe the number of people that all of a sudden told me, hey, Brad, I totally get watch and warning now. But it's just thinking outside the box, thinking a little differently about how we communicate this stuff. A lot of emergency managers all over the country like grabbed my tweet and said, hey, can we use it? I'm like, absolutely, because that's what it's about. Just getting people to understand. There's a taco one now. There's one for margaritas. I'm like, you pick whatever your poison is. If it makes you understand watch and warning, all the better for you. And here's a quick test for you guys. So we've got a watch. Obviously, that's kind of the ingredients. A warning means we've got something, right? There's actually something in between that people confuse and is going away, thank goodness, is advisory, right? So there was an event in Atlanta, Georgia. I think it was 2017 or 18, the snow jam. I can't remember what year it was, but they were under a winter storm watch. And it was up for like 2 days, usually 4 to 8 hours before the event. It's northern Georgia. It's like the Carolinas. Everyone's freaking out about snow, buying up all the bread and milk, going crazy. And then the event gets closer and it looks like, it's going to be an event, but maybe not a whole bunch of snow. And the Weather Service issues a winter weather advisory. Well, a winter weather advisory is actually an upgrade from a watch. It's just not all the way up to a warning. It's the intermediate. But you know what the public thought and the public officials? The mayor, DOT, downgrade. It's good. We went from a watch to an advisory. They thought it went the other way. And everybody got on the roads and they all got stuck. And kids slept in schools and people were sleeping in their cars on the interstate, all because of the communication of the threat, not understanding that an advisory was actually an upgrade from a watch. People thought it was the reverse. So just a small term had a huge ripple down effect on how people reacted. So go ahead and advance. And I'm a big fan of simple communication. I teach a course at UNC-Charlotte in the spring in the department on science communication. One of the examples that I use is the men's and women's room, right? And I have an 11 and 12-year-old. At one point when they were, I think 6 or 7, we went to some trendy South End restaurant. And my son's like, I'm going to go to the bathroom. And I was at the table so I could see him. He runs over there. I'm like, I can see you. Go ahead. He goes over there and he looks at the doors and comes running back, holding himself. And I'm like, what's wrong? He's like, I don't know what bathroom to go into. I'm like, what do you mean? I go over and this is a trendy restaurant. They got some art, like Latin thing on the door. And I'm like, I don't even know which one is the, I'm like, so I asked the waitress, I'm like, she's like, oh, it's that one. And the whole time I'm thinking, I come back and I'm like, I know that probably seemed like a really cool idea to the restaurant owner, like, oh, we'll use some cool artwork and we'll use Latin for the men's. But the point is to tell people where the men's and women's bathroom is. So sometimes I got to check myself on this and think, am I building a graphic or a map or something because I think it looks really cool, but nobody knows what the heck it means? And I did that early in my career. When we had 3D graphics back in the day, we used to build these 3D fly-throughs through clouds and stuff. And I mean, to me, it was awesome. We had Silicon graphics machines. And back then it took like 3 hours to render this thing out. I'd have to start it after dinner and hope to God it didn't crash before 11. Because you get back like, well, I guess I won't use that graphic because it was done. But you render it out and like, this thing is the coolest thing ever. And the whole time you're looking at this, like, this doesn't convey any weather information whatsoever. It just looks really cool. And so we do this a lot in science communication, like, oh, look at this awesome thing we built, or this awesome graphic, or this awesome map. And it's like, if it's not conveying the data, it doesn't really use. And I'll give you an example you guys can relate to with mapping. We used to always use these awesome topographic colored maps as our base maps, which I love. I mean, I have a relief map on my wall of North Carolina. It's like the coolest thing ever. And I love those maps. The problem is that's a data layer if you think about it. The topography and the color. What do? We threw another data layer on top of it. And it was usually green on green. And then we throw another layer on top of it and you're like, I can't see anything. And I remember, using GPS on my phone, when Google Maps goes to the high contrast map at night and it's black and you can see where you're going. I'm like, why aren't we using dark maps? If the data is what matters, the base map should be as simple and easy as possible. So we started going to these monochromatic base maps because now the data was what mattered, not the base map cool look to it, which I love topography. And so we started doing that. And it was amazing how people, oh, now I can see where the rain is, or I can see where the clouds are. But it's just a simple thing that we didn't really think about because we were trying to build cool looking things. So simple communication is a big part of this. We got to stop using all the, I love using a lot of meteorological words, but if you don't explain them or educate people on what they mean, it just sounds really cool to you. And it's great for a cocktail party to use a word, but if nobody knows what it means, it's not great. So go ahead and hit advancement. So how do we stop this? Well, one of the things we started doing at my station, and the Weather Service is starting to do this now, is we kind of simplify the warning process. So this is actually several years old. I think this was with Matthew. We started going to just simple, low, medium, high, extreme. And I will tell you, this is old because I've already learned people don't distinguish purple as being more severe than red. Just so you know, color is very important in our business. Green on a map, we were trying to get away from green for any kind of severe weather, because what does green mean? Good, go, right? SPC, Storm Prediction Center, still has their marginal risk for severe thunderstorms in green. And not only is it well, they use two terms I hate, marginal and a green color does not imply something bad is going to happen. Okay. So we're trying to correct this. So we went to simple, and I think if we just did 3, low, medium, high, because everyone gets low, medium, high. Your dashboard of your car has always had yellow, orange, red lights on it. You know something bad was happening. I don't know what that little battery thing is, but when it's red, that can't be good. All right. If it's yellow, I got a caution. Okay. We all know the stoplight mentality or these colors. So we started going to this for impact graphics to simplify it. And again, this was a map. And as I said, if you know where you are on a map, this is very useful, but not everybody knows where they're on a map. So we use a bar chart form of this as well. Go ahead and advance. So we use it in bar chart form. So the same colors, and we can use it for different impacts. And so the consistency in the colors have really helped people kind of understand. One of the things the social scientists told me about this graphic when we first built it, I had the bar chart in the horizontal. And she said, you should build it from left to right. I'm like, what do you mean? That's the way people read. I'm like, oh. So it's like totally didn't think about this. And just a simple change of where the axis was changes how people perceive that. And you also have to think about in different languages. Some languages are read from right to left and not left to right. So those something to think about. Simple thing I would have never thought about. I just was trying to build a cool chart. And she looked at it and she told me, Brad, I would build this from left to right because that's the way people read. And it would probably be easier to understand threats. Go ahead and advance. So it works in severe weather and rain. We can actually text to it. I think that was under forecasted actually. Still, Matthew was a great event, like, hey, 12 to 15 inches of rain. And guess what? It wasn't enough. It's like 30 inches, that little band that's over the Cape Fear area was crazy. Go ahead and advance. The other great thing about this is, and this has been the hardest part as a meteorologist, is we didn't want to use the same colors all the time for different events, but the public doesn't care. So what we're doing now is we're using the same impacts or colors for different impacts. So if we have a tornado warning, it's going to be red. If it's a flash flood warning, it's going to be red. If it's a severe thunderstorm warning, it's going to be red. If it's a winter storm warning, it's going to be red. Okay? Because the public perceives all those as something bad. And then the follow-on information is, what is this bad thing that you just warned me for? And then you tell them. They don't have to be like snow warnings don't have to be blue and flash flood warnings don't need to be green. We just changed the colors to make them different, when in reality, it made people not take them as seriously. So if we just do red, a red warning light on your dashboard means something bad is happening. Then you look to see what the icon is of what that bad thing is, right? So in weather, all warnings should be red. And this is what the Weather Service is going to. All their warnings will be red in the future. And then they will tell you what this warning is for. There is X warning for your town. It's red color. Here's what the warning's for, flood, and then here's what to do. So it's really become interesting how we've kind of adapted to the different colors to kind of use them in all formats. And this has been really hard for meteorologists because some of my friends, This is the thing you hear often. Well, this is the way we've always done this, or we've done it this way, or this is the color we use in the past. I'm one of those people. I'll change. If you show me data, I'll change anything I do. I'm a big data person. If you give me data to back it up, I'll change my own opinion on anything. That's a human trait. Like what I feel like today feels like the weekend to me. It is not the weekend. I checked the calendar. It's Wednesday. So it doesn't matter what you feel. It matters what the data says. Today is Wednesday on the calendar. It doesn't matter if I feel like it's Saturday. So same thing for us as meteorologists and as scientists, really. It doesn't matter what we feel. It matters, what the data says. Go ahead and advance. So I want to show you something cool that's coming down the road that you guys are actually going to be a big part of. It's called facets. Any guy heard of facets? Okay. So tornado warnings not too long ago were issued for whole counties. Okay. We'd issue a warning for the entire county of Charlotte v. Mecklenburg. It's a huge county, right? Anyone from Charlotte knows Huntersville to Pineville is like a 45-minute drive. It's completely different weather. And nobody wants tornado warnings and sirens going off in one part of the county where it's sunny and another part where it's going on. So we went to polygons back in the late 90s, which is the polygon we kind of did a storm track. But going into the future, and it's coming down the road, but it's obviously in experimental use and the government will spend forever trying to iron it out, will be these facet plumes. Facet stands for forecasting, forecasting and continuum of environmental threats, I believe. It's weird. They love acronyms in the Weather Service. But basically what it is, that plume, it looks like a hurricane cone that you would see for the hurricanes, is going to show where the tornado is and where it's going. So immediately the first thing you notice, it's not over warning. It's only warning for the people in the path. But more importantly, there's people outside the warning that are in that cone. So imagine you're a hospital at the very tip of that yellow plume. That's probably an hour and a half away. You'll have every minute this will update using the volume scans of the radar and modeling. They'll push an alert to your phone and say, you've got a 5% chance of a tornado in an hour and a half. In the next minute, that probability is going to go up or down based on the movement of that storm. And so why would a hospital an hour and a half away need a 5% chance of a tornado warning? Because it takes an hour and a half to move patients from the top 2 floors down to the basement or something. Okay. So the hazards ahead of it, in this case where this warning is now, they wouldn't even have a warning on their phone. Because think about it, they're not in the tornado warning. Also, if I live down here, I'm in the tornado warning, but I'm not in the path of the tornado. Should I be even getting a warning? Probably not. So the way this will work in the future is every minute this will update, your phone will give you an alert. You'll have a continuing threat assessment, basically saying your percentage of a tornado is increased or decreased. So every minute it's either going up or down. And this will help people make better choices. And it'll give them warnings way ahead of time. So if I'm 2 hours ahead of that path and I'm out there, I may not even get a warning until the thing was 5-10 minutes away in the old days. In the future, I'll get a warning 2 hours at a time and I'll say, oh, it's 2 hours away, but I have a 5% chance of a tornado. Oh, I'm in an outdoor festival. We should probably start wrapping this up or getting people to shelter. Now, if you're at home sitting on your couch, it takes me 5 minutes to jump in my closet or less. 5-minute warning's all I need. But if I'm in a mobile home, I'm in an outdoor event, I'm in a hospital, I need like an hour and a half to get to shelter. So this will really help save people's lives. And the technology is now to the point, not only can we track that storm, but the data, the GIS layers that you guys are so used to, is going to help warn the people in the path of that storm much more accurately. Go ahead and advance. So this is a little video. There might be audio that'll kind of show you how this works.
New science and technology are changing the way weather is predicted. Computer models can indicate the probability of all types of weather. No longer is it just science fiction to predict where dangerous weather may form hours from now. Facets, short for Forecasting a Continuum of Environmental Threats, is designed to capitalize on this new technology and make the most of it.
Weather Service Norman, this is John. How can I help you?
When the Weather Service issues a tornado warning now, it's for a very large area, and everybody in that area gets the same message. What we are doing with facets is honing in on the area where the threat is greatest, and individuals will get their own bit of information every half mile, updated every 2 minutes, so that it becomes a personal forecast telling you exactly what your risk is at that location.
The facets information process actually begins days in advance. Long-range outlooks issued by NOAA's National Forecast Centers highlight areas where high-impact weather is possible. As days go by, the outlook locations are fine-tuned to target the location and timing of potential threats. As a high-impact weather event begins, the details of where the impacts will most likely be are displayed with greater and greater precision, giving users a better idea of what safety actions, if any, they need to take.
So imagine you're sitting at this dot and you now see that there is no tornado warning in effect, but your relative threat of tornadoes is starting to increase. It's still increasing as the storm approaches. It's increasing some more. Now the tornado warning is issued. And so for people who have low risk tolerance, like hospitals or schools where they need advance notice, if we can give information indicating that there's a lower risk but it's increasing before the standard warning would be issued, they can take action ahead of time and have a longer lead time to protect the people that they're serving.
We don't want our families out trying to get to schools in a complete gridlock with traffic and storms coming through. Talk about a dangerous, dangerous situation. And so if parents have the ability to check out their kids and do it in a timely manner, that would be most helpful.
Another example shows where you are outside the tornado path, but you're in a tornado warning, but the path of the tornado is actually to the north of that location. So even though they were in a warning, with the facets approach, they didn't get overwarned for an event that did not hit them.
It'll keep us from moving the critically ill patients when we don't need to. We'll have that direct information where the storm's going, when it's going to be there, and we can keep our patients right where they need to be.
While Facets offers many benefits, it also poses some challenges. First, the forecaster must be equipped to use the new technology.
Facets brings with it the ability to speak in terms of probabilities. And forecasters know that there's a probability of many different hazards occurring with a thunderstorm. This will offer them a means to communicate that threat sooner and more efficiently.
The forecaster can now convey a little bit of a risk is increasing and increasing, and that takes the pressure off the forecaster, but it also conveys more information to the end user even before the warning is issued.
Another big challenge is understanding how people's behavior will change based on this new information.
We need social behavioral scientists to help us understand how the information could be useful, how it could be transmitted, assure that access and comprehensibility are there, and bring that knowledge to the people who are creating the technology so that together, through time, we can make a tool that really serves the public and bolsters our collective resilience.
The Facets project represents a fundamental change in the way watches and warnings are done for the country.
And as such, it's going to take quite a bit of research and exploration and experimentation to do it right.
As long as we can assure the information is receivable, is understandable, I really do think that the greatest potential beneficiary of this information is the public and the many businesses, hospitals, and schools that have very particular needs from weather information. This will be terrifically empowering.
To learn more about this research project, visit nssl.noaa.gov.
Thank you. All right. So yeah, this is it's amazing. And the thing is, this has been in the works for years, and it'll take forever to get out there because the government will have to test this several times. The hazardous weather test bed, I was able to take part in that in Norman, and we actually kind of work with this, how this would work in real world. Like how would meteorologists on TV use it? How would apps use it? That's the hardest part. Go ahead, I think we'll go into the next graphic here. But the cool thing is, you know, we often think about getting the warning to people, but almost as important is getting not over warning. One of the problems right now that we run into with wireless emergency alerts, your phone has probably gone off for one of these. It's really loud and annoying sometimes. Is that's based off the cell phone tower location that your phone is hitting, not necessarily where you are. So right now, the polygon, if we're in a tornado warning here, I'd want the warning. But let's say the tower we're hitting is over there and it's in the polygon, we would get the alert on our phone, even though we're not in the warning. So eventually it'll be GPS based off the location of your phone. The problem is, as you know, most people don't like to be tracked at all. So they won't allow them to actually have that access to it. So it's always going to be off cell phone, but they are getting better and better over time. But I think hopefully this graphic. So one of the things that we get accused of a lot in the broadcast industry, and I think a lot of people are guilty of this, is hype, right? I get this a lot, like there's severe weather coming. How do you fight hype? Well, we have a really clear definition of what we consider hype. It's raising alarm without raising awareness. Okay. And there's a lot of this on social media. This is another big dilemma we have. The 10-day forecast of a Category 5 storm in the Gulf of Mexico. I think my social media feed will fill up with that all hurricane season. And in the back of my mind, I'm going like, who's sharing this? That's 10-day forecasting from a model. And I actually keep a folder of all these fantasy storms that people post just to show at the end of the year how many didn't happen, because as a meteorologist, you know that that's not likely to happen. So we're a big fan of kind of keeping away from the hype. It is a struggle with communicating these threats to the public. But that's what we kind of use. And we use something called Weather Aware to kind of keep people aware of the weather without hyping it up altogether. Go ahead and advance. So I'm going to leave up my contact information here. But the reason, I wanted to do this keynote today was to just put in your guys' minds that, we have some really cool tools, technology, and information, but to think about how people are using that is really, really important. For me as a meteorologist, it is really kind of the thing that I think about more so than ever, is how do I get people to react to my forecast so that they don't come up to me and say, hey, I wish I had a job where I could be wrong 80% of the time. Hopefully they'll know that we're not wrong 80% of the time and that we're getting it. Problem is always going to come down to communication and making sure they get that information. And I've kind of come to grips with, I can't reach everybody, right? There's a certain segment of the population that just is not paying attention at all. You hope you can get them, but I always think I'm going to get a hold of their friends, their neighbor, their parents, and hopefully they will pass the information on to them. So it's not a lost cause, but it definitely is something that we can work harder on, is to think about how people use our information from a human standpoint, more so than just a data standpoint. So I have a couple minutes left, and I wanted to leave some time for questions or comments so you guys could ask. And this is your time to grill a meteorologist with any question you want, and I'll try to answer it to the best of my ability. So any questions? Yes. Yeah. Yeah. Okay. Yeah. Great question. So asking, what is the criteria for our verification for our forecast? So for temperature verification, the standard is 3 degrees, within 3 degrees plus or minus. And I know that seems like, oh, that's a huge amount, but that's actually the perceivable difference that humans have in the temperature. I joked earlier about joking between what's 88 and that once they go 3 degrees, people notice that. And then for rainfall, it's binary. Did it rain or did not rain? We don't even use the percentages or the amount. It's because rainfall is the hardest thing, because it could rain in one part of town and not in another. And for sunshine, it's basically, we have pretty good, we break the sky into 8s. And that's how you say partly sunny, mostly cloudy, fair. And so if we verify that based on the number of sky conditions, and that's automated from the airport. So we have to use a standardized location. And for most of us, it's the ASOS at the Charlotte Douglas International Airport. So we're verifying using that point. I'm not verifying for your backyard, because I don't know how quality controlled your information is. And it doesn't go back 140 years. So good question though. Any other questions? Yep. Great question. So basically, as people stream more and don't watch regular TV, how are we going to get the warnings to them? Well, the FCC, in their wisdom, I don't always say they're the wisdom, but they are going to, for streaming services based on your IP, they are going to allow for warnings to break in to your internet provider to give you these warnings. So it will be, the nice thing about that is we have a lot of information from your IP address, really specific information. And so eventually, like Netflix and even like Hulu and stuff, they're going to give access to basically like an ES that would break in to those streaming services via your IP. And really, honestly, for me, social media is my biggest outreach. I'm on TV, and my boss probably hates that I say this. I wouldn't stay up and watch 11 o'clock news, right? It's pretty late, right? And the weather doesn't happen while I'm on the news at 6 and 11. It happens on the weekends, the middle of the night. So I am very active on social media. To me, getting information out days ahead of time via YouTube, my vlog on Facebook, Instagram, anywhere I can reach people, I'm going to be there. During Florence, one of the things that was kind of eye-opening to me was I used to use IG just for personal use, just pictures and stuff. Where during Florence, because it was a really big deal, I started posting updates on Florence on my Instagram, and I wasn't taking selfies, and my following like quadrupled immediately. And it just shows you that there's an audience for weather information on these platforms. People, that's their source of news sometimes, is that social media feed. So you got to be in all locations. And I have friends that, honestly, I had a neighbor that moved into our neighborhood, and it's like, hey, Brad, you're the weather guy from Twitter. She had never watched me on TV. She only knew me from Twitter. And it was like, I knew immediately what I say. It doesn't really matter where you get the information from. I'm just glad you're getting it from me. And to me, it's the content. It's not the distribution method. So I can put it out any way I can. That's what I'm going to do. Yep.
There's a question from the Zoom audience here.
Oh, great.
Is it harder to predict weather in some places, say Wilmington on the coast versus Charlotte inland?
It's definitely more difficult in certain locations. Honestly, anywhere near the water becomes more difficult during certain times of the year with the sea breeze. But I will tell you that the most difficult places to forecast or the most extreme weather are inland areas, like areas of South Dakota, the plains, because you're so removed from a water source, you have such extreme weather. For instance, in South Dakota, their all-time record high is like 122 degrees. In the same state, their all-time record low is like 66 below zero. That's in the same state. Like I always tell people in Charlotte, everyone thinks it's a really hot city. The hottest it's ever been in Charlotte is 104 degrees. I grew up in Cleveland. We were 113 in Cleveland because we're away from the ocean. When you get inland, the extremes are much bigger than near the ocean. The great thing about water, it doesn't allow for wild extremes because it retains heat and it keeps things cooler. So those inland areas and mountainous regions in particular have some of the most difficult areas to forecast. But I think every part of the country thinks that saying that wait 5 minutes if you don't like the weather and it'll change. I've heard that in every place I lived. Everybody thinks that their place is unique. It's really, really hard. But I will say the Carolinas have one unique feature that is incredibly difficult, and that's cold air damming. Cold air gets trapped against the mountains. It's a very shallow layer. It's an inversion. The models don't handle it very well. Unless you live here and forecast it, it is really hard. And it's the reason we get so many ice storms in the Western Carolinas. It is really unique to this part of the country. Happens a little bit on the Front Range of the Rockies as well, but that's a phenomenon, especially in the Piedmont of the Carolinas, Virginia, down into Georgia. In the winter time, that is incredibly hard to forecast. Good question, though.
Thank you.
Yeah.
Thank you for your presentation. I was also going to ask and kind of piggyback on her question previously about social media impact. And so is there, I guess, a kind of a push or an idea or mindset forward thinking for weather stations to have, I guess, dedicated platforms or pages on social media platforms so that they can have the weather or whatever events kind of updated?
Yeah, absolutely. I am huge on social media and really just kind of took hold of it like in the late like 2008, 2009 when Twitter became like a really defining force after the 2008 election. We actually, it's funny, the station, we got on Twitter to communicate with each other on election night. And I remember, oh, that sounds a cool platform. So I started posting stuff for winter weather, and it's like, holy cow, what is this? People just started, gravitating toward it. But we have a YouTube channel just dedicated to weather at my station. YouTube is a very underutilized source, because anyone who has kids knows that's all kids are going to watch is YouTube. So we have a YouTube channel. We have a dedicated Facebook channel. We have a streaming service called WCNC Plus that's on Roku, Amazon. So you literally can watch us without having to watch our broadcast signal, and our app restreams. I was mentioning earlier, I'm in Wilmington. I have a lot of people that follow me here on the coast that don't watch me on TV just because of the amount of coverage I do for hurricanes. And I really realized on the Outer Banks, I would get a lot of questions from the Outer Banks asking about hurricanes. And I'd be like, I'm in Charlotte. Why are you asking? Because I was posting enough updates on a platform that they were seeing and getting information. So we have, and one title that's become more, I would say more expansive in our industry, we have now what's called the Digital Meteorologist. It's somebody who's dedicated to just posting digital updates on weather, not ever being on TV. And I think that field, it will expand. I think that is really going to be where we go, because the great thing about that audience is huge, and the weather happens 24 hours a day. And you really do have an ability to reach a lot of people there. But I love social media because it just gives me an access to the people. And one way I can make myself more accurate is by interacting with people online, because they'll look at their phone and, they'll see that dreaded snowflake on their stock weather app and go, oh, it's going to snow next week. And I'll be like, nah, it's not snow. We're good. And the fact that they asked me to check it for them, I'm like the check and balance for their app, is pretty awesome, because then I can make myself look better by being that voice of reason. So it's great when people ask me about something they see on an app, and that means I know I'm becoming a good, credible source for a lot of people. Great question, though. Yep.
Something that resonates, I know, with pretty much everybody in this room, was talking about maps.
Yeah.
And how people don't know where they are. One of the things I noticed, a couple of the maps you put up had place names in Virginia, where we're from, that nobody knows of, like Verina. There's like 70 people that live there.
Yeah.
Why is that on the map instead of Richmond, 30 miles to the west of that?
So what happens in a lot of our databases, we have these random points of interest, and the software will just pick it based on its location compared to other labels. So it's a spacing issue. And so I've actually had to go in and like remove places or change the name. So we're kind of at the whim of what our database has. And then I really need to tell someone on our staff to go through and start picking out, because there's, like you said, there's places that are just literally like a crossroads, and it shows up as a town on our map. And we can hand select it, but a lot of times when we're making stuff on the fly, we're just using whatever's the automated data point that pops up. But that's a good point. There was one town, it was wrong in our database. It was called Alton, and it's actually Altan. And the nice thing is I can go in the database and correct it. I just got to know about it. So in a growing city, this is also a difficult thing, because there's roads and buildings, like our 3D models of our buildings. Gosh, Charlotte's skyline changes so much, and people are like, you need to update your skyline. You know how expensive it is to make 3D models? It's like, not that you can't use the Google's 3D warehouse anymore for free. It's like, it's hard to get these models to get in there. So it does take some time, but it's a good point. It does happen quite a bit. Sometimes I'll see it and I'm like, what town doesn't even exist? But yeah, that happens quite a bit. And it's just a spacing issue. Like, it picks whatever point is right there and plots it. But good question. Yep. And by the way, if you guys have any good data you can pass to me, I love KML files and KMZ files. They work really well in our system.
Yes. So my question was actually about the data. I mean, we've looked at kind of getting precipitation data from a lot of these sensors that are web exposed, but not actually streaming. So if we wanted to try to predict localized flooding, I guess just from you, do you feel like the environment for sensors is getting more kind of Internet of Things, as opposed to, people like us have to download the data, process the data, and then run a model in that way? I mean, is the direction, is it going that way, where we have more streaming sensors for precipitation, temperature, where we can dynamically model these events?
Yeah, the data collection thing has really become a big part, especially for flooding. Because the one thing about temperatures don't vary as much over my view area as people think. It's like And if 3 degrees is not a big deal, but rainfall varies so dramatically over small areas. One of the companies, and this is not an endorsement, but Weatherflow has these Tempest Gauges. They're non-moving smart weather station with solar panels on it. The whole thing is about the size of my hand. It has a haptic rain gauge, and it has ultrasonic anemometer. So there's no moving parts or maintenance, and they have an open API. And they are installing these things all over the place. And the data is just sitting out there for someone to build a mesonet. And I know in Alabama, I think the power company started working with them to put them on some of their transmission towers with cameras to start building not only a mesonet of weather data, but also have visuals to go with it. So there are some open APIs, and their API is wide open, but we're sometimes at the whim of what the government can get into their system. With the Weather Service, most of their data is open and free, but to get all the weather sensors in there, like we'd love to get backyard data. I'd love to get more barometer data. Weather Signal was a company that was offering the weather data from their phones, the barometric pressure data, which was really cool. And there's a couple of ClimateCell was trying to use data from cell phone towers as well. But it's really fragmented. There's not like a catch-all right now that's gathering, but I'm encouraged by companies like Weatherflow who have created this great sensor, and instead of locking their API up and charging you, they're like, do whatever you want with it. And there's developers just doing all kinds of cool stuff with their API. And anyone that I have 2 weather stations on my roof, and the data is public, and I don't mind if someone grabs the API data and plays around with it, because it's really cool data to be able to work with, especially for flash flooding. Because I think that's where if everyone could get a rain gauge in their yard, that would be amazing. I don't need a thermometer, barometer, but give me a rain gauge, because that is the one thing that changes so much and really would help us out, especially in Charlotte with flash flooding. Look, we're lucky Charlotte has pretty good fins. Their fins program's amazing with their sensors. Some of the rainfall data is incredible. I'm always want cameras too. That's why I trained a lot of spotters. Like, I love eyeballs, like more cameras, and I can see what's going out there. Radar data is great, but having somebody on the ground is like the best weather instrument you can have. That's the great thing about cell phones. Usually it's funny when I'm doing tornado coverage, and it sounds horrible. You see a tornado warning, and I see it going through a populated area. If there's not something lighting up in my Twitter feed, I know it's not on the ground, because there would be so many pictures and videos and people. And so it's kind of like amazing, like crowdsourcing damage paths is pretty amazing on social media. I also use Google traffic data a lot for damage paths, because usually you'll see the path where the roads are all blocked off as they go. So I've pulled that up post-event to look at where all the damage paths are, and you'll see each road blocked off, and you can clearly see where the damage path has occurred and shut the roads down. So the traffic data from Google is really valuable for seeing those almost in real time.
We've got one more question from the Zoom audience. Are you able to crowdsource data from Davis WeatherLink?
Yes, Davis weather links are pretty popular. We use those quite a bit. One of the ways that we get data into our system pretty quickly is through the government, like you were referring to MADIS. If you become a MADIS station, which is a publicly accessible data point, we can get in our system. A lot of the DOT sensors on the roads are already in there. The FINS network in Charlotte-Mecklenburg stormwater, a lot of the USGS gauges are in there. So it's trying to get everything into one network. It's on the Weather Service page. It's amazing. You can see all the different networks they toggle. There's like 1,500 networks in there, and from like Utah's DOT, Virginia's DOT. So it's amazing trying to get all that data. But yeah, we do access those quite a bit.
Thank you very much.
Thank you.
Great job.